All right, hello everybody. Sorry I can't be there with you today, but we're going to do our best to get through the notes that we need to get through, even though I'm not there with you in person. So please make sure you have your packets out. Where we left off yesterday was talking about transformations on page 17 of the packet. And we talked about what it means to shift a function either up, down, left, or right. And we talked about how if it's at the end, it's going to move up or down. If it's in with the x, it's going to move left or right. And which one of those depends on whether we're adding or subtracting. Well, what we're going to look at today is on the next page, so please flip to page 18, a new kind of transformation, which is stretching or compressing. So to stretch or compress the function, something is multiplied to the equation. So just to recap, shifting meant that we added or subtracted something, but a stretch or a compression means that we are multiplying something. Okay? So let's go through first of all and identify all of these parent functions here. So we have y equals 3x squared. The parent function is y equals x squared. Here I have y equals 1/2 absolute value x. Parent function is the absolute value. And here we have y equals the square root of 2x, which is the square root function. And we are actually going to skip this last example here, so you can cross that one off. Okay, so if we graph the regular parent function, the most basic parent function, and I'm going to grab my calculator here. So here's x squared, right? That's our parent function. And I would like you to actually sketch a graph of the parent function. So that's just y equals x squared. Now, what do we have in our new equation? We have this 3 here. That's 3 times x squared. So we're going to see what happens when I graph 3x squared. Okay, so it almost looks like it's skinnier, right? What is actually happening, so let's sketch that. We call this a vertical stretch. Vertical stretch. So imagine that I were to grab the ends of the parabola and pull it up and down. It's going to get taller faster, and it's going to kind of like look like it's skinnier, right? We're stretching it this way. So we call that a vertical stretch. Okay, next example. Y equals 1/2 times the absolute value of x. Again, we're going to just sketch a graph of the parent function. Okay, so there's my basic parent function. Just regular old absolute value. So take a moment to sketch that, because it's good to be able to compare it to the original version. Okay, now I'm going to do 1/2 times the absolute value of x. I'm going to hit graph. Notice that this time the graph is flatter. Okay, in fact, it's half as tall as the original version. We call this a vertical compression. This time, imagine I'm taking both the top and the bottom of the graph and I'm just like pressing it down, okay? I'm compressing it and making it smaller. So we call that a vertical compression. And that was because we multiplied by 1/2. Okay, so let's talk about the difference between a stretch and a compression. Well, the difference is based on what kind of number we're multiplying by. So the key difference here, let's go down to the bottom. If we have a vertical stretch or compression, it will always be at the front, at the very front. And how do we know if it's going to be a stretch or a compression? Well, if the number is bigger than 1, it will be a stretch. So if I'm multiplying by like 3 or 5 or 10, that's going to make it bigger. It's going to get bigger faster. If it's between 0 and 1, then it's a compression. And I'm just going to shorten it to COMP for compression. So if I multiply it by 1/2 or 1/3 or 0.7, any number between 0 and 1 is actually going to make it smaller, right? If I take half of something, that's making it smaller. But if I multiply something by 2, that's going to make it bigger. So stretch and compression. Stretch means we multiply by something bigger than 1. Compression means we multiply by something between 0 and 1. So make sure you have that written down. If you need to pause the video, go ahead and pause it. But this right here is the key. Okay, moving on to our next example. We have a 2 here. Our original square root function looks like this. Again, let's go ahead and just sketch our regular version. Now I'm going to sketch my new version with the 2 multiplied in there. That's 2 times x. And this is what we call a horizontal compression. Imagine I'm taking this and pushing it to the left towards the y-axis. I'm compressing it this way. Now, why is it a horizontal compression? It all has to do with where the 2 is located. If the 2 were out front, like this, according to what we just said, that would be a vertical stretch. Okay, that's a vertical stretch. But the 2 here is in the square root with the x. And we talked about this yesterday with shifting. Anything that is in with the x, in the parentheses, in the square root, in the absolute value, anything that is in with the x, so in with the x, is going to be horizontal. The other thing we talked about is that horizontal always goes flip-flop of what we think it should. Okay? So, if I'm multiplying by something bigger than 1, that's actually going to be a compression. And if I'm multiplying by something between 0 and 1, that's a stretch. All right, so again, make sure you have that written down. Okay, let's try these examples here. I'm going to go through and identify our parent functions here. Okay, so this is our linear function, just y equals x. This is our cubic function, our square root function, and the absolute value function. Now, what kind of transformation do we have? Well, it all depends on where the number is located and what the number is. So, this 6, where is it? It's at the front. So we're looking at a vertical stretch or compression. Now, is 6 bigger than 1, or is it between 0 and 1? It's not a trick question. It's bigger than 1, so this is a vertical stretch. Okay, here's what I'd like you to do. Please pause the video and finish these 3. When everybody's done, press play on the video and we'll check over your answers. So press pause right now for me. All right, let's go through these. So for 2x cubed, this 2 is in parentheses with the x, and 2 is bigger than 1. That means this is a horizontal compression. Okay, here we have a 3 that is at the front. 3 is bigger than 1. This is a vertical stretch. Last one, this 1/2 is in the absolute value with the x, and 1/2 is between 0 and 1, which makes this a horizontal stretch. All right, that is it for this video. We have one more video to go over the rest of the notes on page 19. So flip over to your packet and we're going to talk about flips. See you in the next video.